My name is Cenizal. I'm a UI engineer for a company called Elastic. They were one of the companies sponsoring this event, so I hope everyone got a chance to stop by our booth and get some awesome Elastic swag. I saw a pattern today when we were watching everyone's amazing presentations. I noticed that, especially in Ben's talk and Miriam's, they talked a lot about the problems we face with CSS, the complexity and how to avoid confusion, making things clear. And they also identified the same kind of abstract solutions to these problems, but the way that they actually tackled these solutions and implemented them was totally different, right? They had completely different ideas about the right way to actually solve these issues. And spoiler alert, my talk is sort of very similar. I'm also going to talk about similar problems, similar high-level solutions, but I'm also going to take a very different tack towards how to solve them. The title of my talk is Solving CSS at Scale with Your Own UI Framework. I demoed this talk to my parents, my grandparents. My grandfather fell asleep in the middle of it. My dad had to wake him up. I don't take that as an indictment of this talk. But they asked me, well, what does that really mean, CJ, solving CSS at scale? And simply put, when we write CSS, we tend to find that it gets really hard to add more CSS as it grows. As the CSS code base scales up, it can become more difficult to work with. And so solving it is simply the opposite. It's writing our CSS in a way so that as it scales, as it grows, it becomes easier to work with and easier to write more CSS. So this talk is broken out into two parts. The first is examples of CSS that's difficult to scale. And then I'm going to talk about how I think we can write scalable CSS. So my first example of CSS that's hard to scale is called Cheeky Reindeer Mug. And this is because it is actually this ridiculous cheeky reindeer mug I found while shopping online for the holidays. And this is on a retail website that has 13,000 lines of CSS. It's definitely an example of CSS at scale. And so I said to myself, how were they using CSS to style this descriptive text? So I right-clicked on that descriptive text and I looked in the web inspector. And this is what I saw. There's a lot going on here, right? There's a lot of selectors, there's a lot of styles. So let's dive into this and try to make some observations about what we're seeing. The first thing I noticed is the very long, complex names. As a developer who hasn't written this code, but is looking at it for the first time, I'm trying to divine some meaning here, define some intent, and these long names make it very hard for me to tell what they mean and what they're doing. So I'm already a little confused simply by the complexity and length of these selectors. So let's look at what they're actually doing. We have many selectors interacting on this one element, right? There's a lot of styles here being overridden. It's almost like these selectors are like fighting with each other, right? Trying to dictate control. Each one saying, hey, no, I'm in charge of this element. So for me, it's hard for me to tell which selector is responsible for what. If I had to make a change, I wouldn't quite know where to do it. So let's go back to the way these selectors are named. Let's take a closer look at the first one. It's very complex. So that tells me that it's very tightly coupled to the markup. When I look at that, it's hard for me to visualize, well, what's the structure of the markup going to be? And how is this going to look in the browser? So I actually have to look at the markup in context to sort of piece it together. So let's do that. Let's look at the markup here. Ironically, the markup is also kind of hard for me to visualize, right? The complex selector is defined by all these different parts of the markup. And so looking at this, I cannot really say, oh yeah, this markup is clearly this element with shop list, product list class on it, and it's the li class inside that, and inside of that, I'm sorry, the li tag inside of that, and inside of that, it's this anchor tag with the product name list class on it. So without knowing which selectors are in play, it's hard for me to really tell how this markup is going to appear in the browser. And if we look at how these different parts are disconnected here, we realize that these tightly coupled selectors create very brittle relationships. It makes it really hard for me to make changes to the appearance in the browser by making changes to just CSS or just HTML. If I did make changes to one or the other without changing the other, I might break something by accident. So I have to be very conscious of both the CSS and the markup and how they work together for me to make any effective changes. Get a little parched here. Sorry. So lastly, these complex interacting selectors make it really really easy to accidentally break the UI. Has this ever happened to you where you make a change in the CSS, the designer's giving you a mockup, you've made a change to address the changes you see in the mockup, and you look in the browser and it looks great. Awesome, it looks just like the mockup. So you commit the change, push it, and then a week later, someone comes to you and says, hey, you broke this other thing somewhere else in the app, and you had no idea that that was even related to the CSS that you were touching. That's really frustrating. So these kinds of complex interacting selectors make it easy to accidentally do that. Our next example of CSS that's difficult to scale is Bootstrap. So I love Bootstrap. I know, I'm sure we've all used it. It's really great to use this tool to quickly build an MVP and get something out there that works. But the problem is that it doesn't scale well. It creates this foundation that's really tough to scale. And one of the problems with Bootstrap, I found, is that it has huge files. This is their navbar component file. It's 663 lines long. And trying to dig through that and understand what's there and how to change it, it's really tough. So they didn't really use their file folder structure effectively to organize their code. And what happens is you usually have to just sort of give up, throw in the towel, and just add new classes or new selectors to override the ones they already have. And I can't really talk about examples of CSS that's hard to scale without talking about my own CSS. So a really important idea I want to share with you guys is that when you write non-class selectors, you're kind of committing yourself to complexity down the road. Non-class selectors are things like attribute selectors, element selectors, and of course IDs. So if you're writing selectors like these, they're a red flag that you're already beginning to write unscalable CSS. So this is how it happens, at least in my experience, right? Like I have to create a checkbox component. So I create an input element with type checkbox. Awesome. It looks great. It makes sense. It's obviously a checkbox. And then our design it evolves and calls for a different kind of checkbox. So I'm like, well, I can't use the one that exists now. I guess I'll just create this scoping class that isolates it in the UI, and I'll tweak it. And this style will override what we've inherited from our original input checkbox. And then this happens some more. I have to keep creating more specific selectors to override the ones that already exist. And before you know it, I'm committed. I have no way to add to scale my CSS without adding more complexity and creating more and more overriding selectors, more and more layers of complexity. And before you know it, you end up with cheeky Reindeer Mug CSS. So by starting out with non-class selectors, I've committed myself to scaling by adding specificity and adding complexity. It can happen to any of us. It can happen to you. So this is SCSS. It's a CSS preprocessor language, but it has much of the same syntax as CSS. This is an example of this colors variables file from my first UI framework. And I totally knocked Bootstrap for creating bloated files. I've committed the same sin. This color variables file contained 450 color variables. It was a beast. And I had this idea that by creating this massive color variables file, I can make a tweak to a color variable in one place, and it would ripple out throughout the entire UI and be glorious. I wouldn't have to do any work at all to make changes to the UI. But what I found was that by having these color variables so far removed from the context in which they were used, I had no idea what I was actually affecting by making these changes. I had to actually search through the code base to see where these variables were used in order to understand what the result was of the change I was going to make. It was really hard for me to make effective changes. In SCSS, you can also use mixins to create abstractions. So in this example, I thought it'd be really clever to make Flexbox easy to use. Flexbox, new concept, it's confusing. Let's create a mixin for it. Let's make it even more confusing. Now to use Flexbox, you have to call this mixin. You have to understand what the arguments are, how the arguments actually map to Flexbox, and know what Flexbox does anyway. So I made Flexbox less usable and the code less readable by creating this really bad abstraction using this really bad mixin. So CSS is difficult to scale when it has complex selectors, many interacting selectors, when the selectors are tightly coupled with the markup, when we have a really poor file and folder structure, and when we have confusing, crappy abstractions. Complex CSS is difficult to scale because complexity compounds. When we start out down the wrong road, when we already have selectors using elements and attributes IDs, we know we're in trouble already. Now our only solution to scaling is to add more complexity and more specificity. So here's my scalability checklist. 1, we want CSS that's simple. 2, CSS that's meaningful. And 3, CSS that's organized. So let's talk about how we're going to do this. By applying the scalability checklist, we're going to do this by simplifying our CSS with classes. We're going to give it meaning with components. We're going to organize it all within a UI framework. Let's talk about how to write simple CSS with classes. This means just reducing long, complex interacting selectors that's difficult to scale down to short, simple selectors that are basically just classes. So if we look again at this earlier example, we see that the first selector consists of 2 classes, shop list and product list applied to the same element. Inside of that is a direct descendant, a list item, and inside of that is an element that has the product name class. The second selector is almost identical. The only difference is that instead of having a shop list and a product list class applied to the root element, it's only shop list. But these are very complex selectors, right? They involve classes, they involve very strict relationships, and they involve elements. So I would suggest simplifying these things with classes. Create these very verbose names, product list item name, shop list item name, that apply to that leaf node element. You get a very clear and simple name. You get less, these 2 selectors no longer interact, don't override one another. And I just want to point out that I'm using camel case for these class names. I don't think this is a pattern that's really caught on yet. I love it. Love it, hate it, make fun of it, but maybe give it a shot. You might like it too. So going back to the example I had earlier, we can continue to apply this pattern. We can take these non-class selectors and make them classes. By applying the same rule, we gain flexibility. Now we have a checkbox class, a label class, text area class, and a main class. We gain flexibility because now, if we need to make a variation on checkbox, we can just add a new class. So these selectors we've created become very simple and clear. You can read them, you can understand exactly what they mean. They're much more human readable and friendly. And the markup becomes simpler too. Reading this markup now, we no longer have to worry about a brittle relationship between this markup structure and the class. The class on the element is representative of its meaning. So we also want to write meaningful CSS, and we do this with components. Meaningful CSS is CSS that indicates a clear role in the user interface. And we can make our CSS meaningful by thinking of UI and CSS in terms of components. So what's a component? Well, first of all, a component has a single responsibility. In programming, there's this concept of single responsibility principle. And that means that for any function within the software, there is one unit of code that represents it. And to apply this to CSS, we have to think of our UI. It means that a single requirement of our UI is represented by a single component. Components are also composable. They're like small, fine-grained building blocks that we can piece together to create more complex components. This means that oftentimes we want components to act as containers that we're just going to put more components into. And in turn, those components are also containers we're going to put more components into. This is how we can build a very complex user interface with a relatively simple library of components. And lastly, components are also reusable. We don't want to design components to work only in a single context. We want to be able to use them elsewhere. We want to maximize their utility this way. So if we design components to function in any context, we can reuse them over and over again, even if the user interfaces that we use them in have requirements that we didn't anticipate originally. So let's go through an example, okay? Let's look at this modal component that we're going to build. Here's a mock-up from a designer. It's a new friend modal. Lets us add a new friend to our friends list. And let's go to the process of componentizing this. It consists of a title, form fields, and buttons. So we'll start by asking ourselves, what's reusable about this? I think we should start by working outside in. This is a concept that Brad Westphal actually brought up in his talk at last year's CSS Day I/O. If we work outside in, the outermost component is just this generic modal component. It can be used for any kind of modal, really. It doesn't have to be tied to this idea of a new friend modal. So our modal component, it looks like this in the markup. Just a div with a modal class assigned to it. It has a very clear role in the UI. Just from reading it, you know what it does. If we look at the styles, it has a flex layout. It has flex properties. It has margin, background color, border radius, box shadow. It doesn't have anything, though, that's inheritable. It doesn't have font size, it doesn't have font weight, font color, line height, none of that stuff. Which is great because this means that our children now, any components that we put into this modal, won't have to worry about overriding any of these styles. So this component has a single responsibility: look like a modal, be a dumb container, allow anything to be put inside of it, and don't really care what it is. Continuing on, we can identify more components inside of our modal. We have a modal header, modal body that contains the form, and the modal footer, which has buttons inside of it. If we go back and look at the markup again, we can see how the modal component is composed of these modal subcomponents. It's just this dumb container that we throw stuff into. It so happens to be that the things we're putting inside of it work very well for our needs as developers to build a modal UI. And each subcomponent also has a single responsibility. The header has a margin, padding bottom, border bottom, some flexbox properties. Modal body is padding, modal footer, pretty much the same thing. They also don't care about styling their children. We can put anything we want inside of them and it'll just work. So now that we have, now we finally get to the children, right, inside of this modal. We see that these things are not really modal specific. They have a title, we have some form elements, we have buttons. They're all definitely great candidates for reuse. Let's narrow the scope of our exercise and look at just the form. So what's reusable about this? Yeah, we have labels, cool. Text inputs, sure. But there's something else going on here, something invisible. And it's also reusable. We have a vertical rhythm, right? There's space between these two rows in the form. And it's sort of this idea of a layout. A layout can also be a component. We don't want to apply a margin bottom to labels or to inputs because they could be used in contexts where that margin bottom isn't appropriate. So instead, let's create a custom component to do this layout for us. It's just a very simple vertical layout item component. Like, you can't really get more obvious than that name, right? All it does is when there's an adjacent sibling, it adds a margin top to the element so that these elements get spaced out vertically. And we can reuse this everywhere, right? In any form that needs vertical rhythm. Any body of text where we have paragraphs that need to have vertical rhythm. It'll work there. And it's pretty much the dumbest container you can get, right? You can't even see it. It just does stuff. So if we look at the form, we can see that it's composed of these vertical layout items. The role in the UI is very clear just in the name. Going back to the vertical layout rhythm div, inside of that we see a horizontal space. Again, we can apply the same logic. Let's create a column class, a column component to handle this for us. Same idea. It's invisible. All it does is a layout. And if we look back at our markup, we see that the vertical layout items are now composed of these columns. More dumb containers inside of dumb containers. So now we can fill this layout with the meat of our modal, this form. We have label and text input components, the leaf nodes in our component tree. They don't really contain anything, so we're free to give them styles that would otherwise be inherited. Now we can really do some fun stuff, like dictating their appearance, adding a font size property, font weight, line height. But none of this stuff, though, handles a layout. At this point, the layout's already been handled for us. So when we read the markup, We see layer upon layer of composition, right? We see that our vertical layout items are filled with columns, and they're filled with these form elements. Each component is just a container containing other components. If we go back and look at an inspector at the leaf elements in our component tree, it's very obvious what it does. And what's great is that you don't see any overriding styles. That feels really good to me. So it's so much easier to understand compared to our cheeky Reindeer Mug CSS. And these components that we've created can be used to create other components. We can create something like this, like a friend details modal. We can also create a confirmation modal, all using the components that we've just created through this exercise. This component-based approach results in this great library of user interface components that you can reuse. They're sort of the building blocks of your user interface. From this, we can create things like forms, navigation, any column-based layout. So, to sum it up, components impart meaning, right? The selectors have a clear role in the UI, and from reading them in the markup, you can sort of visualize what it's going to look like in the browser. So when you write your components, remember, we want each component to have a single responsibility, it has to be composable, and we want it to be reusable. So once we've written our CSS to be simple with classes and, meaningful with components, we need a way to organize it, right? So this is what our UI framework is for. Our UI framework represents the body of our CSS, organized in such a way so it's easy to find what you're looking for and easy to know where to add new stuff. There's three aspects to the UI framework I want to talk about. The first is the file and folder structure. The second is a class naming convention. And lastly, I'm going to talk about how to use CSS preprocessor tools to effectively create and organize your UI framework. So file and folder structure. I like to put the UI framework inside just one directory. It makes it really easy to find, even if this is being used inside of another project that depends upon it. This can help separate the reusable, composable components from any CSS that may still be very tightly coupled to your markup, very UI specific. I like to organize the components also in their own folders. Each component gets its own directory, and inside of each directory is also another index.scss file. This is the file that's imported by our root index.scss file. It's going to be responsible for aggregating all of the SCSS files in our component directory. It may seem like a lot of boilerplate to create this file just for something like a button. It only has that one button SCSS file. But when we add more involved components like our modal, and there's more SCSS files that need to go in there, it comes in handy, right? It's really nice to be able to encapsulate all these files inside of one directory. And check out how cool it is, right? To have a UI framework full of components. I love coming into work and seeing something like this. When I have to build a user interface, I know that I have these tools available to me. I have all the building blocks necessary to just put together a UI quickly and robustly. I can be confident in my work. So the class naming convention, let's talk about that. It's a way to define types of classes. Right? It's a way to define types of classes and how they work together. So the convention I like to use is basically BEM, block element modifier. There are others out there that were mentioned in another talk, OOCSS, SMAC CSS, Suit CSS, and even Bootstrap has its own naming convention. So they all share something in common. Mine, I just try to keep it really simple. I try to distill it down to just the bare essentials. So let's go through another example and talk about the naming convention in this context. Let's go through the example of a button. Here our designer has provided us a mock-up of a button. You can see that we need to have two different types of buttons, a basic button and a primary button. We also have a state, a pressed state. This is how the button needs to look when it's been pressed. And we also want to support the option of putting an icon inside of this button. We're going to explore 4 different types of classes to build this button. The first is a base component class, then a modifier class, third a state class, and lastly child classes. So I'm going to show you how this naming convention helps you clearly identify the role of each type of class. So the first is just the base component class, really simple. In previous examples, we were already looking at this kind of class. In our case, building a button is just called button. The styles we have here are used to establish the foundation of this component. If you look closely, you'll see that it's defining a lot of stuff here, but we don't see anything like background color or color. There's no border color. And so that's because we know that the different kinds of buttons we're going to have to create will need to change these properties. So if we look at the button in the browser, we see that looks pretty boring. That's not a very interesting button, and it doesn't look like the ones that we need to create, but that's okay, because we're going to use modifier classes to tweak the appearance of this button and customize it for each case. We have here a button dash dash basic class and our button dash dash primary class. These are our modifier classes. And we can tell their role because they're coupled here. They're used in the same situation with the base component class. The dash dash is used to tell us that's a modifier. So when we're scanning our markup, it's really easy to understand what is what. And if we look at the styles, we see that they just fill in the holes left for us by our base component class. They really don't need to do much. They do just exactly what they need to do. And going back to the browser, we can see how they've customized the appearance of that base button. Now let's talk about how to make this pressed state. Each button needs to look a little bit different when it's been pressed. This is where state classes come in. We're going to use state classes to do this. So an example of states would be things also like a hover state or a disabled state, a selected state. In this case, we only care about pressed state. If we look at the markup, here's how each button would look when this class is applied. The button dash is pressed class. You can tell it's a state class because it has one dash and it has the word is in the suffix there. And you still know, though, that it's tied back to the button base component because that has the name button in it, inside of it. So people sometimes ask me, like, what's the difference between a modifier and a state? Seem kind of similar. And the difference is really that a modifier will live on an element during the entire lifetime of that element. It's never going to be taken off. But a state is going to be added to an element and removed from an element, typically through JavaScript, depending on user interaction or whatever other logic. So over the course of the lifetime of that element, it may have that class on it or it may not. So we can look here in the styles and see that we have our button is pressed state class. We have one per modifier because the state of each will look different. And it's nested here. When this is compiled to CSS, we're going to incur a little bit of specificity with these selectors. But I think that's OK, because we're never going to want to change the appearance of each modifier when the state's applied. If you want to change the appearance of it, you're just going to change the definition of this state class. Finally, we get to child classes. Right? We want to support the ability to add this icon. Child classes are classes that are very tightly coupled to the base component. They're not going to work outside of it. In this case, the icon only makes sense when used inside of a button. So let's take a look at the markup. We have here our button and button primary classes applied to an element. And inside of that, we have another element with the button underscore underscore icon class applied to it. So that underscore underscore, that's what tells us as a child. We have that distinguishing shape to the class so that when we scan our markup, we can say, hey, there's a class, there's a class, there's a child class, there's a child class. It's all coupled to this base component class. You understand the role of these classes inside of the markup. In the SCSS, child classes are indented beneath the base component class. This gives us a couple things. One, as humans, when we're scanning the styles, it's easy for us to spot the indentation and understand, hey, there's a relationship here. These are child classes, very tightly coupled to the base component class. But by not nesting it, we're avoiding incurring extra specificity that we'll later have to deal with. So to recap, we have 4 different types of class names in our naming convention. We have our base component class, our modifier classes, state classes, and child classes. Each one has a different name shape to help identify its role and differentiate it from the others. So let's talk about how to use preprocessor tools effectively. Preprocessors like SCSS and less give us great tools like mixins and variables. They let us create abstractions around our logic and around the different properties of the values of different properties. And if we use them wisely, we can use them to help us scale our CSS. So you remember that colors variable file I showed you earlier, the 450 lines of colored variables, completely unwieldy? So when you prematurely generalize like that, you end up introducing a lot of complexity that you could have avoided. A lot of complexity that will actually impede your scaling and slow you down. I found that it's a lot better to globalize gradually and only when necessary. So this is about how as local as you can get with variables. Right? This icon size variable is scoped to just this class. You can't use it outside of that. And the great thing about this is that you can make changes now to this variable with confidence. Right? You can see exactly where it's going to be used. So you don't have to search throughout the code base and make sure you're not introducing adverse side effects. If you need to make a variable more global, I've found that the next step is generally just moving it to the top of the component definition file. In this case, though, this variable now is accessible throughout our entire code base. It's essentially global, even though semantically it's just scoped to our component. So the important thing now is to name it uniquely and meaningfully, so you know, A, this variable is tied back to this component, and B, you won't collide with any other names. And if you really do need to create some global variables, I like to create a global directory inside my UI framework directory and put all the globals in there. You can see here, I have a colors SCSS file, and by following this pattern, I was able to keep this one down to 45 lines. Mixins are another really invaluable tool that preprocessors offer. I found that the best way to use them is to use them to create abstractions around UI patterns. So for example, let's look at these text input and text area components. Now we know that they both do sort of the same thing, right? You can click on them, you can add text to them, they can be used in a form. They behave similarly in our UI. And they both look very similar. They have a gray border, they have some placeholder text that looks very similar, which is great because this means that the similar functionality is represented to us as users by a similar appearance. In this case, they also look similar when receiving focus. They both just have this blue border. If we look at the styles, we can immediately spot the similarities, right? If we wanted to define the concept of a form field in our UI, then these styles are that definition. We can use a mixin to encapsulate these styles. By naming it semantically like field, you know what it represents. If we ever need to change the definition of what a field meant in our UI, what it looked like, we now have one place to go to. We don't have to look throughout all the implementations of form field in our SCSS to do that. So now when we look at the text input and text area components, we can spot the use of this abstraction. And we can say, hey, this is a form field. They're both form fields. And I know what a form field is. I know what it's going to look like in the UI. I know how it's going to behave. So we're gonna to organize our CSS in the UI framework, we want to use a clear file and folder structure. We want to use a consistent naming convention, and we want to make a smart use and an effective use of preprocessor tools. So we're getting to the end now, and I don't know about you, but I really want to go to the after party and drink a few beers. So I've talked about a lot today, right? There's a lot to absorb, and I'm sure if you're thinking about trying to apply this to your own CSS, there's probably some practices in place that this would fight with, and if you did want to try it, it'd take a lot of work. But I want to leave you with a thought. This is an investment, right? And I think it's paid off for me, so I think it'll pay off for you too. If you invest time in these ideas, you'll notice a couple of things. You'll notice that your framework is going to grow over time, and it's going to do so steadily, because you're writing it with scalable practices. And as it grows, you're going to notice something else. As a corollary, you're going to notice yourself spending less time writing your CSS and more time just thinking about the UI and the UX. When you have scalable CSS, you can develop your UI faster and better, fewer bugs. This is the payoff of your investment. So to recap, scalability checklist. You want to keep classes simple and short. You want to make them easy to understand. By doing so and keeping specificity low and using just classes, we're avoiding that doomsday scenario that we saw with the cheeky reindeer CSS. We all want to use components to add meaning to our CSS. You want your components to have a clear role in the UI. So you can look at them and know exactly what they do. You can read the markup and know exactly what it's going to look like. And we want to use a UI framework to organize this simple, meaningful CSS. You'll use a file and folder structure so that everything has its place. Your naming convention will help you understand the meaning of the CSS when you're reading the markup. And if you're using preprocessor tools like mixins and variables, you can create useful abstractions around your UI patterns to make your CSS more meaningful and understandable. And that's how I think you can solve CSS at scale. Thank you very much.